So this is all great. Like a car knows what it is, so that's great. But what if we want to actually do things with this car? So now here I'll go into defining methods. And so with methods, we again have to define. So let's define one method as drive. So methods are kind of like functions, except they're a little different because they have a reference to themselves. So in every method, we also always pass in self. And then what we do is we also, let's say whenever I drive, I also want to know how much gas I use. So I'm just going to use gas. And then if it's the case that my used gas is greater than the amount of gas the current car has. So each car has a reference of its own gas. Okay? Then I want to return the fact that I need more gas. More gas. Okay? And then otherwise, I want to have some notion that I actually drove. So I'm going to print out some idea that I drove, and then I'm of course going to have to use gas to drive. So self.gas is going to be reduced by whatever my used gas is. Alright, so let's see how this works. So let's take a look at how this works. So now I'm basically going to first exit out of Python, reload this file. Tesla dot. So I have to redefine my Tesla. Okay, so now my Tesla.gas is 20. Now if I drive the Tesla, so now I'm actually doing something with the car. So if I drive it and use 10 gallons of gas, well, obviously it drove, but let's see how much gas there is now. There's 10. So now the Tesla has some notion of how much gas it has. So now let's say I want to take the Tesla out one more time and drive using 15 gallons. This obviously shouldn't work. It says I need more gas. Okay, so now I want to figure out a way, how can I fill gas up? Well, I have another method. I can define another method for that. So this is the idea of object-oriented programming. We can basically add functionality to the idea that we have. So when we need something, we just add a method. So what we can do now is, let's say I want to basically fill the gas. Okay, and there's no real, so I'll just pass in self in this one. Also, notice, I forgot to mention this, notice that I only passed in one argument here. So self is always bound to Tesla. This is why this entire process works. Self is implicitly bound to the object we call it with. Or in this case, this was defined within the constructor because the constructor implicitly bound self to Tesla. Okay, so again, that's a really hard concept to wrap around, especially because everything else seems so defined in the course. So this is a little hand wavy, I will admit. So, but that's how it works. Okay, so now if we want to fill the gas, what we need to do, well, if the gas, so basically, what I want to do is I want to increase the amount of gas. So, how should I do that? Well, I guess at the end of the day, I can just do self.gas. Let's just assume I automatically go to full tank, and then print I have a full tank. So how I define how I want to fill the gas of a car is up to me, but this is how I'm going to define it. It's very simple right now. So right now the Tesla needs more gas, so I'm going to just so now let's just do this entire process again. So make my object, and then drive. I see I have less gas. Drive again, being very reckless, and then now, thankfully though, I have a way to fill gas. So now I fill the gas, and notice that I don't pass in self. I just fill gas and I get full tank. Let's check what Tesla.gas is. And it's 20. So now it's a full tank. So the reason this entire process works is because self is bound to Tesla in our constructor. So whenever we do anything with self.gas, the entire Tesla attribute changes. Now, something also pretty cool is I can define another car. So let's say I have a BMW. Okay, so a car that's a BMW. And it's black. Alright, let's say it's brown. Actually, brown is an ugly color. Sorry, blue. Blue. Okay. So BMW has a particular amount of gas. Turns out that it has the same amount of gas as the Tesla. But let's say I drive the BMW. Now the important question to ask yourself is, after I execute this statement, should the Tesla's gas change? So this is a key idea. So take a moment to think about whether it would change or not. So my basic idea is, my question here is, if I click Tesla.gas right now and figure out what it is it going to be 20 or is it going to be 10, which is the BMW's gas? Oh, by the way, BMW.gas should be 10 by now. So yeah, it's 10. So now the question is, what is Tesla.gas? So that's the big question, and the answer is it's 20. And really, of course it's 20. That only makes sense because it would be crazy if I could drive my BMW and I could affect the amount of gas a Tesla that was a completely different car had. So this is why object-oriented programming is so important, because each of these objects are independent of each other. So the reason they're independent is because they have these instance attributes, and these instance attributes are particular to a car. Each car has its own model. Each car has its own color. Each car has its own gas. And doing something with one car shouldn't have any impact on another car. So that is the key idea here in object-oriented programming. And I do want to briefly talk about the class attribute up here that I've shown. So class attributes are a little interesting because they pertain to basically every object. So a BMW and a Tesla, BMW number of wheels is going to be the same as a Tesla number of wheels, no matter what. So that's true. Now, what the interesting thing is, you can also, because it's shared among every single car, you can actually access the number of wheels by just using car, because in general, every car is going to have 4 wheels. So that's why they do that. But the thing you can do is you cannot figure out what a general car's gas is, because there is no notion of a general gas, you know? Each car has its own gas. So this doesn't make any sense because car has no attribute of gas. So that's the key idea here. You can only access the gas by using the object. So we've been using the object to get the gas. So you can do Tesla.gas, but you can't do, so car is a class, but you can't do car.gas. But you can do car.numWheels because that's shared among all members of the class. So here's some subtle differences between class attributes and instance attributes. So I'm going to go a little more into that. But now let's look at a summary of what we just did. Alright, so the first thing we have is we have a constructor. So a constructor is basically what creates particular instances of a class or an object of the class. So here I made a Tesla by calling, it's not exactly a call expression, but we're basically initializing the class or the object in this case. So because of this, now we've created a Tesla that has an attribute of a model, a color, and a gas, and it also has a number of wheels. So this is how we basically create an object of the class. And then once we have an object, each object has a class attribute, or potentially, and this is actually shared by all members of the class. By all members, I mean every single object. So notice that the BMW and the Tesla had the same number of wheels because it was a class attribute, but they might have had different gas, different notions of how much gas they had left. And that's the idea of instance attributes. This is shared only by a specific object of the class. So notice here that a Tesla.gas had 20. It could have been possible that BMW.gas had a completely different gas, but that's separate. These are independent because they're within and they're instance attributes. They're shared only by a specific object. So this is how object-oriented programming, this is the rules basically. I'm giving you the rules of how this entire game works. So, and you can't access instance attributes by using the class name. And lastly, we have methods. And methods are what classes can actually do. So attributes are inherent properties within a class or an idea the idea that we're trying to portray. But if we want to actually do something with it, we need methods. So methods allow a car to drive or fill gas. So this is an example of that. So, and whenever we use methods, we always have a reference to self because we're usually referencing the particular object's notion of what its properties are. So if a Tesla drives for a long time, it should know that it has lost a lot of gas. But if a BMW just drove, it should know that it has a full tank. So that's the entire idea with that. And also, you've seen a lot of this dot operator, so it's all over the place. And the dot operator is actually used to access methods, instance attributes, and class attributes. So whenever we do have an object dot some name, those are for instance attribute and class attributes only. And then whenever we have some type of call with either no arguments or some number of arguments, those are for methods. And then notice that whenever I called the method, I did not pass in anything for self. I just pass in whatever, if there was an extra parameter or no parameters at all. Because self is a reference to the object itself. You don't need to pass in the object to itself. Alright. Now, quick note about instance attributes versus class attributes, because this is something that confuses everyone. And basically, the dot operator will first check instance attributes. So let's say that a Tesla had its own notion of gas, but there was also a notion of gas, a class attribute called gas. It would first check the instance attribute because it cares about itself first. So think about classes as kind of selfish, hence the name self. Okay, that's a joke. I'm pretty sure that Python didn't name it as such, but just something I thought of on the fly. But anyway, so it'll first check self.gas, and then if there's no instance attribute, it'll then check class attributes. So that's how that works. And then know that instance attributes are particular to an object, and you cannot access instance attributes by using the class. Class attributes can be accessed by the class because they're shared among everything, so it doesn't really matter how you access it. So that's the entire idea there. So whenever you're designing, with object-oriented programming, it's not so much about the actual code. There are many ways to design things, but when you're designing, always keep in mind of what you want a specific case of your design to have, and that should be an instance attribute. And if there's something within your idea that's shared among every instance of that idea, you should use a class attribute. So those are the two design principles for today. And then methods, use them often and make sure they do something very specific. And I mean, that's basically all there is right now to object-oriented programming. We'll be talking a lot more about it in the next video because I think it's such an important concept, because this is object-oriented programming is what actually changed software engineering entirely. It changed the way we looked at programs, and it made programming a lot easier because now we can just design systems that can change over time. And the good thing about object-oriented programming, it's very easy to maintain. So let's say, for example, I want to add functionality to a car like autopilot. So I can just have a method that does autopilot for me. So that's the whole idea with, I mean, obviously this is not in the actual world. In the actual world, it's a little more complicated than that. But in the programming world, this is how we compartmentalize things. So object-oriented programming is very good for maintaining code and also designing systems that change over time. Anyway, that's all I got for today. I hope you got something out of this because this is a really important topic, and I'll definitely talk about it more. I'll see you next time. Thanks.